Hello everybody, it's Kenneth and welcome back to another video. In today's video, I kind of wanted to briefly go over a few SAT practice like math problems, not really in a structured order, just so that it's more similar to the actual SAT experience. And I'm going to be experiencing these firsthand so you guys can see my thought process here. So immediately for the first question, we have an inequality and it says, what's the solution to the inequality? Well, immediately I see that both sides are like divisible by 4, plus we're trying to isolate x, so we can divide both sides by 4. And what does this result in? Well, this will result in 4 is less than negative x. So now to isolate x, we have to divide by negative 1 on both sides, or multiply by negative 1, either works. But you have to remember, the kind of trick question that they're trying to test here is, do you remember that when you multiply or divide by a negative with an inequality, the sign flips? So what I basically mean is that instead of going like negative 4 is less than x, it's going to go that negative 4 is greater than x, or x is less than negative 4. So the sign flips. So pretty much, we're going to have to find that answer choice here, and that's the answer. Okay. Pretty simple. Just have to really remember that one trick. So let's move on. Okay. Two equations, if x1, y1, and x2, y2 are distinct solutions to the system of equations shown, what is the product of x1 and x2? Well, the easiest way to do this is go to Desmos and put in the equations given. So I can't really copy them, so I have to type them. And then our second one is 7 minus 2y equals 15x minus x2. So now we have to look for our two coordinates, and you can see that I zoomed out a little bit to find them. Well, we have what looks like 2/3. You put that over here. I know that's not going to stay, but and then our second looks to be about 15. So our second x-coordinate is 15. And the only reason we're looking at just x-coordinates is because it's looking for the product of x1 and x2. Now, if we remember, the product is multiplying them together. So what's 15 times 2/3? Well, 15 times 2 over 3 is equivalent to that, which is 30 over 3. So it should just be 10. Perfect. So really use Desmos to the best of your ability. Now let's see what else we got. Which of the following is equivalent to the product of 2/3 z minus 1/2 and 6z plus 12? Well, the product, remember, is multiplication. So we're going to have to multiply these. Now you can do this by hand or you can do it in Desmos, but I'll do it by hand first. So 2z over 3 minus 1/2, terrible z, I know, times 6z plus 12. Well, we know that 6 divided by 3 is going to be 2, so it's pretty much 2z times 2z. So we should know that the first term is going to be 4z squared, which means we can eliminate these first two. And then the second thing it's looking for is there a middle term? Well, let's see. Because 2z over 3 times 12, well, 12 divided by 3 is 4, so we get 8z. And then plus 6z times negative 1/2, and 6 over 2, negative 3, so plus negative 3t, or z, which leaves us with 5z. So we know that there's going to be a single variable in our thing, first degree, and so it has to be d. Perfect. Now, next question. The diameter of a circle graphed in the xy plane has endpoints at negative 23 over 15 and 1 over negative 55. Well, the first thing I'm noticing is that it wants us to find the center. Now, the best way to do this is to add up the endpoints, like negative 23, because this is a diameter. The diameter contains, it contains the endpoints, right? But they're not just random endpoints. They are the diameter. They make up the diameter. So they make up the whole, or twice the radius of the circle. And that's important because you need to find the radius of the circle to do the question. So we have negative 3 plus 1 and then over 2. And so basically what you're doing is you're averaging the two endpoints to find the center point. So we get negative 22 over 2, which is negative 11. So we can already eliminate these two, because if you remember, let's say this is our h. The center is going to be x minus h squared plus y minus k squared. So given that x minus negative 11 is x plus 11, which is why that's the only options available. And then we see that y plus 20 is the only option available there too, so we don't even have to do the math for that. Then to find the radius, we can use the distance formula here. Now, if we remember, the distance formula is x2 minus x1 squared plus y2 minus y1 squared, where y2, x2 are a point, and y1, x1 are a point. So the distance here, and the distance here is finding the diameter. So the radius is actually 1/2 the distance. So we can say d. So let's say that the distance is the square root of 1 plus 23 squared plus, and we're adding because it's negative 23, because you're subtracting negative 23, so that's adding, plus negative 55 minus 15 squared. Now what does this go to? Well, this looks like a good example for the use of decimals. So let's get rid of this. We can erase all of this. And so let's see, square root of 24 squared plus negative 70 squared. So 74. Now remember that the radius is half of that. So the radius is, yes, 37. Now remember that in the circle equation, you have to square the radius. So we're going to have 37 squared. So, and that's 1369. And so we see, remember that C and D were our only answer choices. And we found that the radius squared is 1369. So that's going to be our answer here. Yes. Okay. Now, in the figure, line segment AB is vertical and BZ is horizontal. Line segment BT has length 9 and is perpendicular to AC. So let's draw, well, that's already drawn. The length of BC is 15. Approximately what is the value of H to the nearest integer? Well, what I think we can do here, or what I'm seeing, so we can actually look for the hypotenuse of the main triangle here. For example, I just realized that you guys may not have been able to see the open board the whole time, but hopefully you understand what I was talking about even without the drawings. But anyways, should be able to look for the hypotenuse AC here. We won't be able to find it immediately, but should be able to look for it, right? Because we get that 15 squared, which is just one side of this big triangle, plus h squared equals AC squared. So we get that AC equals the square root of 15 squared plus h squared. And then one thing to really remember, you might have to remember this to like just like figure it out, is that the altitude, which is this 9 here, the altitude of a right triangle is equal to the leg 1 times leg 2 over the hypotenuse. So in our scenario, leg 1 is our h, leg 2 is our 15, and the hypotenuse we just found. So square root of 15 squared plus h squared. Now if we put this into decimals, we might, or we should be able to find h. So we get 9 equals 15h over the square root of 15 squared plus h squared. Let's just make this x, because x is a variable that decimals recognizes. And we get closer to 11 than 12, and it asks for the nearest integer, so let's just say 11. Right? Well, it's not that hard. You kind of just have to memorize that the altitude is like leg 1, leg 2 over the hypotenuse. But if you see it on it, like, they may want you to do it a different way, but that's just like, I feel like that's the easiest thing to memorize. Now this is a much easier question. what is the slope of the line? Well, we have to isolate y, so we have to remove 8x from both sides. So we get negative 6y equals negative 8x plus 1. And then to isolate y, we still need to divide by negative 6 on each side. So, and we only care about the x term here because that's what is affecting the slope, or that's what the slope is affecting. So negative 8 over negative 6, get rid of the negatives because they cancel out, and then 8 over 6. If you divide by 2 on the top and bottom, that reduces to 4/3. So that should be the answer here. Yes, okay. And then I guess this is probably the last question I'll do. The chambered nautilus is a deep-sea creature with a spiral shell that can withstand pressure up to 1180 pounds per square inch psi. Underwater pressure consists of atmospheric pressure, which is 14.7 psi plus 0.45 psi of hydrostatic pressure per foot of depth underwater. To the nearest foot, what is the maximum depth underwater at which the shell of the chambered nautilus can withstand the pressure? Well, pretty much what we have to do here is just add 14.7 psi plus our 0.45 times x here. We'll just say x is our feet. Well, it has to be less than or equal to 1180 because it says it can withstand pressure up to 1180. So I guess we should really just do less than here just to be safe. Then we can put this into decimals. Not that bad. 14.7 plus 0.45x is less than 1180. So what is the maximum depth? Is about 2590. Let's see here. Well, let's just go 2589. Exactly.